So today students will be studying a program on implementing stacks using linked list. Okay. So we are going to implement stacks using linked list. That means we need to declare the structure for a node. So the structure for a node is declared like this. Okay. So a node is having two parts, data part and the next part. And like you know, a stack always has top of the stack a variable which shows where the push and the pop operation has to be performed. That variable has been declared here, and initially since the stack is not present, we do not have any stack with us, we set it equal to null. So the initial value of top is equal to null. Okay, so basically these nodes, your stack will be created in the form of a nodes of a single linked list. Okay, so these are the function prototypes for your push, pop and display. Then we use a menu driven program to display the choices to the user. So basically what we mean by menu driven is we have one loop running like this. Okay, so this is the while loop. So we have put here value equal to 1. That means this loop will be true. It will be true infinitely. Okay, so we can exit it only if some criteria is fulfilled. I'll tell you later what is the criteria for exiting this loop. Okay, so right now we want this menu to be displayed infinitely. Okay, so what is the menu that will be displayed? This will be the menu that will be displayed. So 1 will be push, 2 will be pop. You can see here 1 will be push, 2 will be pop, 3 will be display and 4 will be exit. Okay, so then you will ask the user to enter one of these numbers 1, 2, 3 or 4. Okay, and by mistake if the user enters a wrong value, then you will tell him that it's some wrong selection, try again. Okay, once the user enters a choice, you will use a switch case, a switch statement to do all these operations as per your menu. So your switch case will deal with this. Case 1 will do with push because you have put here 1 as push. Case 2 will do with pop. Case 3 will be the display and 4 will be exiting your program. Okay, so understood. So basically that is the duty of your switch case. In case 1 you will write a code for the push. You can write the code or you can call the function for push. Similarly, case 2 is for pop, case 3 is for display and case 4 is for terminating your program. So in case 1, we want some value to be pushed onto the stack. So we ask the user to enter the value to be pushed onto the stack. So suppose he enters the value as 40. So then we call the function push function and we pass the value 40. Okay, this value 40 has been entered by the user from the keyboard. So once we call this function, the control is transferred here. Inside this function push, 40 will be inside this variable value. Okay, then we declare one temporary variable of the type struct node. This structure we have already declared on top. So in the first line here, this line is very familiar now to you. You have already studied the program on linked list. What this will do? It will allocate memory for a node. Okay, and that node will be pointed by this variable new node. Basically in diagram form, it will look something like this. So you are going to create memory for a node, and in diagram form it will look something like this. Okay, so your say the node has been created with the memory address as 700. Then going over to the next line, we enter the value that is to be pushed into the node. So the value that we wanted to push onto the stack was 40. So we enter that value 40 inside the node. So the node is, as you know, has been divided into two parts, the data part and the next part. So the value that we need to store is in the data part. We access the data part using this code, new node arrow data. We store the value there. The value that we are storing there is 40. Like you can see here in this diagram here. This diagram here represents that code. Okay, you've entered the value there 40 using this programming code. And this is your first node. Also, it is the last node in your single linked list. If it's the last node in your single linked list, you know that the next part should contain the value null. So in the next programming statement, we make the next part equal to null. Okay, so we'll see how it is done in the program. Here you can see. So if we check if top is equal to null, if you remember, initially we had made top equal to null. Why this top was made null? If you remember, I've told you this. Why? Because the stack was not yet created. Now the stack has been created, so we have to change the value of the top. Okay, top has to point to the first element in the stack. So we check if top is equal to null. What we have to do? New node arrow next. New node arrow next means this area here. Okay, this is new node arrow next. So that area there should become equal to null. Why it should be null? Because the last node in a single linked list is always, the next part is always null. Now this is your first node, also it is your last node. So this value here should be null. We make it null using this programming statement. New node arrow next equal to null. So that can be seen here in this diagram. Okay. If this statement has been executed, the if statement, else statement is not executed. So we go to this next line. What is next line does? Till now you can see, till this first three steps that we have done, top is not there anywhere in this diagram. Okay, in this three diagrams that I have drawn here, top is not there anywhere. But as you know, top should be pointing to the topmost element in your stack. So which is the topmost element in the stack now? This node here. Okay, is top present here? No. So we have to make top present here at the topmost node. How we do that? By using this programming code. Top equal to new node. So when we do that, what will happen? Top will be now present at this node with the address 700. Remember that here also your variable new node also will be there. It's not like new node will not be there. New node also will be there. But the moment you exit this function, okay, new node is a local variable. So the moment you exit this function, new node will get deleted. Okay, the new node will get deleted. That's why originally I had shown you only this variable top, which is a global variable. Now top is pointing to the topmost node in your stack. So this is your stack. Top is pointing to the topmost element in your stack. Okay. Let's see another push so that you understand this properly. So again, suppose I go to the main function. So after you exit, you push the value, you will break from the switch statement. So you will exit from this switch statement, and you do not exit but from the while statement. So you will come back here, you print these values. Okay, again you will display the menu and you will enter the choice. So suppose you enter the choice as 1. When the choice is 1, again switch choice. So that means you will be going to choice value is 1. So you will be going to case 1. So again in case 1, you're going to enter the value. Say enter the value from the keyboard as 5. You're going to enter push the value 5. So call the function again, push function. Now this variable value will contain the value 5. So again there's a temporary variable. You create a new node. Now by this variable new node. Previously node that is present here. Okay, that was 40 you had created. Okay, here this is null. Sorry, it should be null. The same value here should be present here. It is null. So this same thing is here. What you had created previously, and now you have made a new node. Say the new node has got a memory address as 400. Okay. So next step, you enter the data in the new node. So the data that you are pushing now was 5. So we push that value into the node. So here you can see the data part, this is the data part. So new node arrow data gets the value 5. Okay. Now if you just look at this diagram here, this is going to be your topmost element. Okay, this is going to be your topmost element, and this here will be your bottom element. Okay, basically if you look at it in the terms of array, this 5 here is the top element, 40 is the bottom element. So that is what I'm trying to say here. 5 will be the top element, okay, and 40 will be the bottom, just like in this diagram. Okay, so now if this is going to be your top and this is going to be your bottom, there has to be some way of linking this node with this node. Okay, we link it like this. I want here in the next part of this, in the next part, I want the address of this node, which is already present in your linked list. So we are already having one value here, 40. We are already having a value here, 40. And, okay. So this is that value 40, which is at the bottom. And the new node that I have created should be the top. What we do, I want here the address of my node containing the value 40. So what I do, I use this programming, new node arrow next equal to top, because top contains this address 700. So I write here new node arrow next. New node arrow next means I refer to this part. New node arrow next is this part, and top contains this value 700. So when I execute this line, 700 will come here. So your this diagram will change like this. When 700 comes here, a link gets formed from this node to this node, like it is shown here. Okay, that means your 5 is inserted, or your 5 is pushed on top of 40. Okay, now we have pushed 5 on top of 40, but where is top? Is top there at the topmost element? No, top is not there at the topmost element. So in the next line, in the next line of code, we make top go to the topmost element. So that is done by using this line, top equal to new node. When you execute that line, top will go to the topmost element. Like I told you in the previous push, here new node variable also will be there, but the moment you exit this, new node will be deleted. Okay, so basically what I'll just show you the program code now. So here we had inserted the data that was in this line here. Then we check if top is equal to null. And when you check if top is equal to null, value of top is 700. So it's not equal to null. So you go to the else part and you execute this line. New node arrow next equal to top. That is this. So when you execute this line, one arrow gets formed between, or link gets formed, you can say, between the two nodes. So 5 becomes the topmost element and 40 is the lower element. So next step is to move this top to the topmost element. So that is done using this line here, top equal to new node. So when you do that, you'll get this. Okay, so that is how push works. So if you would enter another element, a new node would have been created. Okay, and the same process would have got repeated. So suppose you would have entered the value here and formed a link between this node and shifted top on top. You would have got a third one, and like that you could continue. So you would have made one new node here, enter some value, say 23. Okay, then you would store this address 400 here. So this and this node would have got linked. Okay, would have linked this node like this. They link this node to this node, and then your next step was to take top to the topmost element. So this is the way you would have got the top of the a stack 45, 23, and so on. Okay, I'll just undo this. That is how you would have kept on pushing. You can keep on pushing till you have place on your hard disk. So it is not like a array where your place is limited by the size of the array. Here you can keep on creating nodes as long as you have place on your hard disk on your computer. Okay, so you can keep trying. You can try to push some more times and check it out. So I'll show you how pop works. So if I would go back to the main function after this, again your menu function would be displayed. Okay, so these options would be displayed, and I would enter the option now as 2 pop. When I say pop, okay, when I say pop, I would go to case 2. So in case 2, I would call this function pop. When I call this function pop, I'll go to the pop here. So I check here if top is equal to null. So when you check here, value of top is 400, not null. So you go to the else part. In the else part, you give the value of top to one variable temp. So you will get here temp. So you will get here temp. Top is also there, temp is also there. Then you print the value that is present there. So you print this value 5. Okay. The next line, since you're going to delete this topmost value, you're going to delete this. Okay, you're going to delete this. So what you have to do before deleting, shift your top. Before deleting, you would shift your top. For example, here you are deleting 5. When you delete 5, your top should go to index 0, or it should go to the value 40. The same thing we should do here. When you are deleting this 5, top should go to 40. That is done using this programming statement top equal to temp arrow next. So here we are doing that. We are shifting a value of top to the lower element. Okay. Once we do that, we use this inbuilt C function to delete the memory pointed by temp. So that inbuilt C function is free. So free will delete this memory. So it will delete this node pointed by temp. So once you delete it, only this node remains, which is pointed by top. So this is how your pop function works. Okay. Display function also is similar. Here you give the value of top equal to temp, and you keep on moving to the next node till you don't temp is equal to not equal to null. Okay. You don't need this last line. So that is how it would work for you. Okay. So I hope you have understood how this works. And if you have any doubts, then you can ask me the questions. Otherwise, you can just practice pushing and popping some more times. Okay.